All right, everybody, this is Avantika, and we're gonna go through my presentation about reverse engineering. This is gonna be very much an introduction to how I believe one should learn reverse engineering. I'm pretty much a beginner, and I always consider myself a beginner in anything I learn that keeps me grounded. But yeah, this is how I believe one should learn reverse engineering. Let's go with it. Um, let's see who is our detective. I'm calling myself a detective because I'm going to tell you a story. It's in the form of the story that I'm supposed to present. This is me, Avantika, and now who am I? Pretty much, my username is I am Avu. You can go ahead and find me on the internet. Maybe you'll find a lot of information about me. Good. Uh, find stuff about me. It will be amazing if you find stuff about me. I dabble quite often in security. I used to make music sometimes. I love memes, and as usual, I love to break things. So yeah, this is gonna be how I want to see reversing. Me as a detective, I'm wandering across this ones and zeros. You're about to go in a tech world, and you find a lot of this tech. There's routers, there's this applications, there are various frameworks, and you get to know about these things. As a hacker, you want to know how it works. You want to understand how it works. You want to know how the router is sending DNS packets and whatnot. It's very interesting for you. And I believe that's a very important thing as a skill to have is to know how things work. And that's what makes it interesting. That's what changes from the mindset of a programmer to an hacker. You want to know how things work so you can later break them. So, as you're wandering around in this tech world, you come across a very strange binary. Now, what are binaries? Well, binaries are just compiled programs. You wrote some code and you are like, okay, let's compile this, and you'll see it get a binary. What is compilation? Essentially, it is putting your code into one piece of box. You can see I got a box here, a pretty cool box. Looks very cyberpunky, if you ask me. So that's the compilation part. So we're gonna do a demo live side by side, and let's go ahead and get on with it. So you come across a very strange binary, and this binary is called crack me friend. Interesting. What is this strange binary? What is going on? Let's have a look at it. A common command that you'll come across when you're reversing is a very simple command called file. File crackme.friend. It tells you information about the file. Pretty simple as that. A file crackme.friend. You can run this against any file and it's going to tell you what the file is all about. It does it by something called magic bytes. It's not going to look at the extension of it. It's going to look at the magic bytes of the file. Well, why do you, or you ask what are magic bytes? Essentially, this is like a little header, a little cap a file is wearing, which tells, oh, I'm an executable. Oh, I'm in JPG. It tells the file command that, and that's how we go about it. Now, the crack me friend is a executable file. It has some stuff written over here. Not important as of now, but feel free to Google about it. I'm not gonna tell you much about what these terms mean. I want you to Google, and that's another important skill that I believe you should have is Googling. A lot of a part of your journey in reversing is going to be Googling. You're not going to know everything. You're not going to know every word. That's where it comes in. You do not know something, copy it, Google about it. And there you go. You're going to read about it and then come back to your reversing time. So we got it. We have a nice binary called crackme.friend. See, let's try running it and see what it does. Okay. It asks you for a passcode. Well, let's see what a passcode is. I'm just gonna enter a random passcode. Random passcode. Well, it says, poof, time to RMRF the world. Whoa. The sky is about to delete all of the world, and we surely do not want that. What if we enter the right passcode? Maybe we can save it. Maybe we can save the world and finally, finally get around our hero complex. So let's reverse the binary. Let's understand how this binary works and how we're going to do about it. So, a common tool that we go around in reversing is called GDB, which stands for GNU Debugger. And I'm going to run that over on Crack Me 5. Don't worry about what this font debugger is. I just want you to show colors. Everybody loves colors. It's easier to understand with colors. Okay. Now I want to know what functions are there. What are functions? It is just the code block of code. So I'm gonna run info functions. You can see there are a lot of functions, but remember, focus on what's important. For me, the important function is main because it literally says the main function. So I'm gonna disassemble the main function. Wow, those are a lot of stuff that I clearly don't know about it. It says there's some assembly code for a main function. I don't know what's push. I don't know what's RBP. Wow, this is very scary. What is reverse engineering then? What do I have to do all of this? Well, reverse engineering is essentially understanding how a thing was made. A simple example that I love to give when I'm telling people what reverse engineering is, well, your mom made a very nice pizza and you love pizza. Your mom is not telling you the secret. How she makes this perfect cheesy pizza, you do not know about it. She just gives you and you eat it and you enjoy it. But how does she make that? What sort of spices and cheese and sauces she uses in what amount and with what order? That's reversing. To figure out what stuff goes around and how, that's reversing. Reversing can be applied anywhere. I gave an example of pizza. You can also apply it on applications, and that's what we're about to do. We are about to reverse this application. But wait, how do we do that? How do we even reverse stuff? To reverse stuff, you must know how it was made, right? You can't understand how to reverse a pizza without knowing how to make a pizza. So it's called forward engineering, opposite of reverse engineering. Duh. So what is forward engineering again? Well, forward engineering is known as programming, which we are quite familiar with. So programming is forward engineering. You program stuff and then you compile it or you make something. And to understand that, we go the reverse way, which is reverse engineering. So a quote that I've often heard on internet is to break something, you must know how it is built. I repeat, to break something, you must know how it is built. So make sure you know how things are made and how to break them. So a simple tip is try to code programs. Try take out a program, write hello world in it. Any language doesn't matter. It's easier to start with C or C++. Compile it, look at its disassembly, and you can go about it. We're gonna get into that shortly after, but let's see how that goes. Okay, now that we know what is reversing and what is forward engineering and this weird stuff of assembly, let's try to do it. Let's do some stuff. Let's reverse this thing. It's time for reverse engineering. Okay, I'm gonna quit this. Way too complex. Let's see what we can do. Okay. One more thing that I love to iterate is thinking simple. Quite often, when I do CTFs, let it be cryptography CTFs or reversing or sometimes web, I like to impart the idea that things are simple. You should always approach with the things to with a simple mindset, knowing that things could be just simple. Approach it with simple. I used to play some CTFs and quite often I would come across a challenge which I had solved previously in some other manner, and I would be like, okay, I know what to do. I'm just gonna go with this algorithm. I'm just gonna crack this, and it doesn't turn out to be that way. It turned out to be completely different, And it's weird that it turns out to be different because I did not think simply. It was all completely different. So think simple, act simple, you might just help it out. So quite often we try complex stuff. I want to remind you that thinking simple helps a lot. It's the simple thing. So as I said, it's reversing time. We're done with that. Let's think simple. Let's think just simple. We'll go about it thinking simple. What is thinking simple? Well, there's a super ultra simple command called strings, which essentially prints out strings, a text in all of the binary, whatever text is given out there, it prints out the text. Hmm. Well, a lot of text here. How do we go about this? How do we go about this? Let's read it. Oh, you see enter passcode and then it says I am root and says shucks, no more RMF the world. Poof, time to RMRF the world. You know what? Maybe the password could be I am root. Just let's just try. It doesn't hurt to try. That's one more thing. It doesn't hurt to try. Always try things. It's very important that you try things. Uh, People often are like, okay, this might not just work. Let me not try. So why? It's important that you try things. Doesn't matter if it's very simple. Doesn't matter if it's very hard. You try things, and that's how you're gonna learn things. So try things. So I'm gonna just enter the password. Oh, it's still RMRFing the world. Our world is still dying. We need to somehow save it. Well, we did do assembly. I, w- I was very, very, very scary. We did not know how it would go about it. Um, how do we go about it? How assembly is so scary. How do you go about that? Well, what I believe is assembly looks scary. I'm not gonna lie, it looks very scary. The first time I saw it, I was like, wow, what am I doing supposed to do this? What is this stuff? What is offset? What is this? You learn. Reading assembly is more important than writing assembly. You're not going to spend much time writing assembly. You're not going to spend time. You will. I'm not denying that you will not. You will spend some time, but reading assembly is more important than writing assembly. So that's the thing that I want to remind you once again that reading assembly is very important. But how do I learn reading assembly? You just It's a very simple trick. You just pick up any code, as I mentioned previously, go about it, get that code, read assembly. If you don't understand anything, copy it, paste it into Google, and there you go. Now you can read assembly. It's a step by step thing. It's going to take a long while to go about it. Now, our Well, now what is this very complex thing? How do I go about it? How am I going to understand what to do right now here? So, but you know what? Let's go back to our notes. Let's go back to in the past. Let's go back into the past. Take a back into the past and we'll see how that is. So, I have a very simple HelloFriend.c code written here. It just includes the standard library, standard header, with for input output. So we can print and get inputs from the terminal and use. There's a main function, very simple. It returns an integer. As you can see, it returns an integer. And then we have printf hello friend. I've compiled it here for us for easy access. I'm just gonna run the hello friend. As I expected, as we all expected, it's just gonna print out hello friend. By the way, that's a reference to Mr. Robot. It's a really great show. I believe everybody should watch it. It's a really nice show. Okay, well, now what? Now we're gonna decompile it. Again, same thing. We can use GDB. Hello, friend. We're gonna disassemble the main function. Same thing. It's a very small code this time, which is good. But I want to introduce you to a very simple technique, which is comparing assembly and C. It helps you with understanding what part does what. So there's this really lovely tool called God Bolt. There's also another one called Dog Bolt. Check it out. Maybe you like that. Uh, where's my Hello World? It looks like I don't have my Hello World here. I'll just paste it out. Yep, there you go. Hello World is here. It's compiling. Boom, we got it. So doesn't have the stdio. Main function is there. Oh, there's this. It highlights the code for you what it is doing. Now, what is push RPP? What is move RPP, RSP? What is that? Well, uh, I want to explain this, but I've written some comments over here for what the code does actually. So let's have a look at that. It's the same exact code here. You can, compare and everything, but I've written it in assembly and I've added some comments for us to explain it. This will come back to later. It's fine. Saves the current base pointer onto the stack. Let me zoom out a little. This is better. Saves the current value of base pointer onto the stack. So there's an RPP which looks like the base pointer. What is a base pointer? Well, you know what is a stack? Stack is, imagine it as a big box or a big cylinder. The, the pointer which points to the base of the stack is known as, well, base pointer. So it saves it onto the stack. Why is it saving? Because somebody called main. There's a guy out there who calls main and main calls other functions. So somebody called main and we are saving it. So whenever our main function gets over, we're going to go back to that point. Then we set the base pointer to the current stack pointer. So we know where to move now. So we just set the base pointer to the current stack pointer. We know how to move now. Now it says move EDI, which what is move function now? We move things. You move some data into register or memory into register. You can move stuff around. MOVE. It's similar to that, but it's not MOV. So we are loading the address of hello friend. You can see the address of hello friend is here. Well, what is this LC0? Well, LC0 is just a label. You segregate memories with labels. Okay, you this is hello friend and this is for this. You put it a name, a label over there saying that LC0 belongs to the hello string friend. Now, we have got the hello string. Wanna put it into EDI. What is EDI? Again, a register. Wait. You did not tell us what registers are. Well, registers are like super ultra fast storages. They work very ultra fast. They're present on your CPU and they were like blazing fast storages. That's how it works. So yeah, I'm gonna load hello friend into EDI register. Now I'm gonna move 0 into EX. So I want 0 is usually when we are returning something, which means exit success. So it means that, okay, program exited successfully or function was called successfully. So I'm gonna move EAX into that. Well, why are we moving into EAX again? Because whenever a function returns something, it's gonna return the whatever the value was in EX. So we want to make sure it returns successfully. And then we're gonna call the printf function with the address of the string as an argument. So printf, we go to C, hello friend, gonna call that back again and it's gonna print our statement. We go back here, let's see that. See, we'll just hello friend. You have seen that it's, oh wait, highlighting the proper thing. It's highlighting the proper thing. It's gonna move all of that, call it and print out our hello friend. Well, that's good. Again, we're gonna move EX into 0. We're gonna pop the RPP, so it goes back. Popping means removing something on top of the stack. You just like pop it out, and we're gonna finally return the main function, and then the code is gonna go back. The control of the code is gonna go back to the function that called main. That's why I put the RPP there. So yeah, okay, this is a little helpful. Now I know what is a push, I know what is an RPP, and I know what call is, and I know what pop is. Helps a lot to me, to be honest. Um, let's go back. Okay, now one more thing that I want to iterate is sol, flags, flags, and shells. When you're gonna go about and reversing, it's gonna look very complex. It's gonna be wow, what is this? This is confusing. What do I do? Okay, so the important part, as I mentioned, is focus on what's important. Focus on what needs to be done. Quite often, you don't have to reverse all of the program. You don't have to understand all of it. Maybe it's needed, but quite often you don't need to. Just have to focus on something that is very important. That is your goal and that is your target. So once you focus on what's important, it's easier to detangle the stuff and, well, get it straight. So let's go back and put it here. When I go back to the thing again, I have the whole thing disassembled here. I have the code for the crackme.friend. I see crackme.friend.c. Simple, very simple. Let's have a look at it. We include some header files. There is a reverse string function. We'll come back to that in a while. But then there is a main function. It takes an input of 100 buffer. It asks for you the passcode. That's what happened, right? And then it takes your input. This is just for, well, taking spaces. And then it reverses the string, whatever we input. And then it compares if the reverse string is equal to I am root. And if it is, then it prints shucks. No more RMR in the world, sad Pepe. And if it is not equal, then it's gonna just, RMR of the world and return zero. That's what main function does. Let's have a look at the reverse string function. It is just gonna swap the characters. As you can see, swap the characters and start at the end and move towards the center. Very simple algorithm. You don't have to worry much about it. As I said, focus on what's important. So yeah, let's go about it. Again, you can disassemble in GDP or you can disassemble in Cardboard. I've done that. It's a little easier to compare, as I mentioned. Let's go to the main function. Again, push RPP, Fun fact, this is called function prologue. So, a prefix, a prologue thing that uh, assembly does or the code does before actually executing the function. Same. Now, again, I've added some comments for us to explain it better. Crackme.friend. Don't worry about it. Looks like a lot of comment, but as I said, let's focus on the important part. Same thing, saves the best pointer. Now, this 112 is allocating some space on the stack for local variables. As we have some local variables here, so it's going to save some space for that. Okay, now we just clear up the EX. Again, you can go ahead, read all of this, and this code will be available on my GitHub repo. All of this will be available on my GitHub repo, so you can go ahead and read all of this. But I want to check out what's important, so let's have a look at that. So it's going to call the reverse string function, as I mentioned, and it's going to reverse all of the string. That's one. And then we have this string compare function. Interesting. We also saw that here. Crackme.friend, reverse string function, and then we have string compare function. Let's have a go back to it. And where is it? Where is it? Where is it? Where's the main function? Here is it. Okay. This interesting thing called test ex. What does that mean? Well, it is just a comparison part of it's gonna check if the ex's value, which is what you put, is also equal to ax. If it is not equal to, jump not equal to, then it's gonna jump to L5. Where is L5? L5, L5, L5. Maybe it's at the down. Yep, L5. It's gonna print out LC4. Let's see what LC4 is. LC4 is poof, RMR of the world. So if that's not equal to, then it's gonna RMR of the world. Well, that's little confusing, isn't it? Like, how do I know what's the flow of the program? Well, there is again another nice tool called IDA. I mean, you can also use Ghidra, but doesn't matter. I just like IDA's perspective, IDA's the way it looks. It's very pretty. I've installed IDA. Let's load it up. By the way, this is the free version. Um, yep. Anyway, see, you got a nice disassembly, and you can see it tests the EX, and if it is true, then it's gonna, sorry, if it's false, then it's gonna, well, RMRF the word, and if it's not, then it's gonna, well, not RMRF the world to be honest, and then it returns. So you can see a nice control flow. You can understand what it does. IDA helps a lot with this. Play around with IDA, play around with tools. It's very important. You can look up a nice tutorial online, and you'll understand quite a lot when you go about around this. So yeah, I'm not trying to bombard tools on you. I'm just trying to remind you that there are tools. You explore them, helps with life to make your reversing easier. So well, we got that much. I'm just gonna pop off the IDA, save the thing, they're good to go. So we understood what it's gonna do. We'll go back to God bold. See, it's gonna test EX. Jump not equal to. If it's not equal to, it's gonna jump on all five, and that is LC4 is RMRF. And if it is equal, then it's gonna jump to L6. L6 is sorry, I messed up. Yeah, if it's equal to, it's gonna jump not equal to. But if it's equal to, then it's gonna jump to LC3. LC3 is shucks, no more RMF in the world. So now we understood the flow. If the string compare function is equal to I am root, then we are not gonna do this. So well, let's run it. Let's crack our friend and let's see what we go about. Let's do that. So we need to enter a reverse string of I am root, which is, well, let's see, tur ma I. Shucks, no more RMFing the world, and that's how we save the world. Let's go. Congratulations, everybody. The world is saved. It's no longer RMRFing the world. By the way, RMRFing means deleting everything. Okay, but wait, Avantika, you said always think simple. What is that? Why are we thinking simple again? See, I mentioned we need to think simple, and I'm gonna explain a very simple way to crack this out. Let me just, I'm just using a very simple program called Ltrace. What it does, it tracks what kind of processes and functions and everything that you open up when you're doing running a program. Quite useful. And just let's just try to enter hello here. Oh, we can see it reverses the string and it tries to compare to that. Easy, I figured it out. I don't even have to open Ghidra, IDA, disassembly, nothing at all. I just have to enter Surma I am root, I am root. Shucks, no more RF in the world. We solved it. We solved all of this just because we thought simple. That's what I wanted to iterate again. Think simple always. Well, that's done. That's good. We're not saving the RMRF. So how do I be better? How do I be better at all of this? What is the key to be better at all of this? Well, it's simple. There's no roadmap per se, but I do wanna, tell you some tips and tricks. Number one would be ask questions. Doesn't matter if you ask the wrong question, that works too. As people say, there is no such thing as wrong questions, only wrong answers. So ask question. People will get irritated, but then you'll understand that, well, okay, this question is wrong way to ask. Maybe this is the right way to ask. That's important. So ask questions. That's gonna be great thing to do. Secondly, this is very important. I spend so much time doing this. There is no perfect resource. There's not no such thing as perfect resource. I used to go around about and I will like, okay, let's find a resource of C that has everything and everything. I spent hours and days in finding that. I would find that, and then I would go through it, and then I will like, okay, this is not working out. This is not something that I can understand. And then I'll be again, okay, let's find another perfect resource. Doesn't work. There's no such thing as perfect resource. Sorry about that. So you just pick out any resource, start with it. If you don't understand something, Google about it. You'll find another resource. It's jumping between resources. That's how you learn it. There's no such thing as perfect resource. It's a very thing that important thing I learned while I was learning reverse engineering. Secondly, well, how do I get around it? How do I start reverse engineering? Well, simple way, choose your architecture. What do you want to crack? What do you want to reverse? Do you want to reverse something that runs on your PC, or do you want to reverse something that runs on your Android phone, or something that runs on your Mac OS? Choose your platform and choose your architecture. Then choose your compile language. What do you want to in which language do you want to reverse? Do you want to reverse something in Go? Do you want to reverse something in Rust? Do you want to reverse something that is written in C or C++? Again, choose that. Learn how it lives. Learn how the operating system starts. Learn what happens when you click a binary. What processes does it do? How it works. Learn the life of the code. As I said, to know how to break something, you must know how it is built. And now we're adding in one more information, how it runs. Once that's done, you're good to go. You can do anything and everything you want. Just pick out all the stuff. Remember the points I've had. And then that's that when we have reverse the reverse engineering. Thank you everyone for whoever joined. It was lovely giving a presentation with you. I appreciate all of you. Thank you so much.